This here. So f prime is indeed going to be cosine. Can someone give me the next piece? What cosine of what? Of x cubed. Yep. And times what? 3x squared. Right. Exactly. Because you have to use which rule is this? This is the chain rule. Nice. You had to do the derivative of the inside. So another way to write that would be, f prime of x is equal to cosine of x cubed. That was, what did you do? You did the derivative of what? X cubed. What is the derivative of x cubed? 3x squared. Are we okay with this? Do you remember this? This should be kind of familiar-ish, right? Kind of familiar-ish? Okay, so with that information right there, what is the integral? Don't write anything down, just look at the board. What is the integral of 3x squared cosine x cubed dx? What is the integral of this? What is the integral of that going to be? Sine of x cubed, exactly. Sine of x cubed, and you put the plus c on there. We just showed that the derivative of this is this. So what's the integral of this? Sine of x cubed. Is everybody with me so far? The derivative of this is cosine x cubed times 3x squared. So what's the integral of this? There we go. I'm just trying to see if you actually can verbalize something. Sine of x cubed. Are you with me on this? Yes? You're all there? You're just breathing? Okay. Got it. The challenge here is going to be when I ask you just straight out, what is the integral of that? Why were you able to do this right here? Why were you able to do B?
Because we knew what A was.
We knew A. I led you to it because I showed you the path in one direction, and therefore you could go back the other direction. The challenge is this. If I don't give you that first part, how do you integrate something like that? And that's what w-substitution is going to help you do. So, for example, on this one right here, now how would you test that to see if it worked? How would you test it to see if it worked? Find the derivative of this thing, exactly. So if you do this, what's the derivative of sine? It's going to be cosine x squared times the derivative of the inside plus 0, because the derivative of c is 0. And what's the derivative of x squared? So it's 2x cosine of x squared. Nice. So did it check? Did it check? Yes, it did. Yay, happy face. Okay. What about this one? Try that one out. So you did negative 2 cosine of x squared plus c. And again, how do you test that? You do d dx of negative 2 cosine x squared and see where it leads you, like this. Well, what's the derivative of cosine? What is the derivative of cosine? Negative sine. So you have negative 2 times negative sine of x squared times 2x, the derivative of the inside, plus 0, because that's the derivative of c. So, oh look, there's your 4 right there. So what do you end up with? Oh, and that turns positive. So you end up with,
why is that 2 positive?
Because 2 negatives is a positive. There was a negative to begin with right here. There was a negative there and a negative there. So a negative times a negative is a positive. So you end up with 4 sine of x squared. So does that check? Yay, it does. What was the new thing that was added in here, Zach, that you had to take care of when you did this one? What was the new thing, the slightly new element? The coefficient. You had to put this right here. There was that 2. There was that 2 you had to take care of. Okay, so let's keep practicing. Let's keep practicing. This one right here, let's say you didn't see this right here. Let's say this wasn't right there. I want to go like this. Woo, like this. Yay. Let's say I did that. What we're doing with w substitution is undoing the chain rule. These you could effectively do in your head. These 2 right here, I asked you what they were, and you could do it by like strict investigation. You're like, oh, you undo the sine, cosine. Okay. It gets to be too much to track in your head without a system. If you try to break down some of the chain rule ones, going in the opposite direction, you can't just do it by looking at it. You can't just do it by looking at it. So, for example, this one right here, it says evaluate each of the following. This is the integral of e to the 4t dt. You might be able to do this in your head. You might be able to do this in your head. Well, what's the integral of e to the x? What's the integral of e to the x? E to the x. The integral of e to the x is e to the x. So the answer to this is probably going to have e to the 4t in it. What's the derivative? What is d dt of this? What's d dt of e to the 4t? What's the derivative of e to the 4t? What's the derivative of e to the 4t?
E to the 4t.
E to the 4t times? Times what? Times 4, the derivative of the inside, right. So is that exactly what we want it to be? Is this what we want it to be? Is this what we wanted it to be? It is not, because do you see a 4 in front of that thing? No. So if that 4 is in front of that thing, but we don't want it to be there, what could we add to the beginning? What could we add right here? What coefficient could we add to get rid of that 4? 1/4. So let's try this. What is the derivative of 1/4 e to the 4t? What's that derivative? Well, you can just, the 1/4 is along for the ride. It's going to be 1/4 e to the 4t times what? Times what? Times 4. Ah, so now what cancels, Lizzie? What cancels now?
1/4.
The 1/4. Oh, so is this what we want it to be? That is what we want it to be. Now, here's the thing. We did that by guess and check. We did it once, and it was off by a factor of 4. So what did we place at the beginning? A 1/4 power. Now, is guess and check something you can try? Sure, but will it get too complicated? It's getting there. So let's try something a little different. So we're going to try this a second way. It's going to erase that. We're going to try it this way. This right here says w equals 4t. This is a nice substitution we could do. W equals 4t. If I take the derivative of both sides, ignore this for now right here. Let's say I just took the derivative here. What is dw dt going to be equal to? If I take the derivative of both sides, dw dt is going to be equal to what? If I take the derivative of that, what's the derivative of 4t? Yeah, 4. Yes. Are you okay with this? Is everybody okay with that? Okay. Now, here's something I'm going to allow you to do, which you are allowed to do, but you haven't done before. This, you can also rewrite as dw is equal to 4 dt. You're allowed to do that. You are allowed to separate that. Is everybody with me so far from this step to this step? Are you okay? Is everybody okay with this? We're good? Can someone tell me what dt is equal to then? What is dt equal to? Yes, dw over 4. So let's circle these two things. And now let's go back and look at this one. Well, we wanted w to be 4t, so we could now rewrite this as the integral of e to the what? E to the what? Factor out to the front of this integral. What could I pull out to the front? There's only one constant in there.
1/4.
The 1/4. This is 1/4 times the integral of e to the w dw. Oh, what is the integral of e to the w? We just know what the integral of that is. What is it? What's the integral of e to the w? E to the w. So now you have 1/4 e to the w plus c. What does w equal again, everybody? 4t. W equals 4t. So now what do we have? 1/4 e to the 4t plus c. Hey, is that the exact same thing we got before? Yes, but this gives you a process for finding this 1/4. Okay, sit down, please. Can someone tell me the difference between the presentation of question A and question B? What's the key difference between the presentation? There's something very different about B than A.
They tell you a W.
They don't give you a W. They don't give you a W. The most challenging part of W substitution is coming up with what you think the W should be. So looking at part A here, does anybody have a guess what we think W should be on this one? What do you think W should be on this one, Connor? Looking at part A, looking where W was, what do you think W should be on this one? So let's try that. That's a great guess. So the first thing you're going to do, step 1 is going to be to guess a W value. Step 2 is going to be to differentiate that. Differentiate. Nice. So if we differentiate this, can someone tell me, Connor again, dw dt is going to be equal to what? What's dw dt equal to? Yeah. No, we're differentiating, so there's no c. So what does dw equal? 2t dt, right? Is everybody with me so far? So what does dt equal? What does dt equal? You got it. Finish it for me, Connor. Over. Yes. So we have the two things we want. We have w and we have what dt equals. So you have find, in this case, dt. So now what do we do? What do we do with those two things once we find them? What do we do now? We take those two things that are circled in yellow and what do we do with them? Gabby, what do we do with them now that we have those two things? What did we do over here once we had those two things? Yeah, we substituted them in. So we're going to substitute. We're going to substitute these in. So can someone tell me, what does the integral become now? The integral of 2t e to the what? Gabby, 2t e to the? W, right? But instead of dt, what do we write? Yeah, dw over what? 2t. Now, there's something about this integral that is very different than what you're used to. How many letters do you see in that integral? That is something you have to be very careful about because we don't know how to integrate multivariable equations. But there's something we can do right now that helps us out a whole lot. What's the magical thing that happens right now? What?
We don't have the t squared plus 1 back in.
Oh, okay, we're not putting anything back in. Just look at that integral right here. Jen, look at this right here and tell me, is there any simplification we can do?
Get rid of the 2t.
Exactly. Look at this. So what do we have now? E to the w dw. Is that about as nice as it gets? When you get to cancel things like that, that means you're on the right track. What's the integral of e to the w? We know what it is. What is it? E to the w plus c. But in this case, what does w equal, Connor? You told me. What does w equal? So the answer to this is e to the t squared plus 1 plus c. All done. To see if it's correct. How do you test this to see if this is the integral? What do you do to this? We took the antiderivative to get here, so what do we do to test this? Take the derivative. If you do the derivative of this, it's e to the t squared plus 1 times the derivative of this. What is the derivative of t squared plus 1? 2t, and that goes up front. Is that where it should be? Yes. So choosing your w is definitely the most challenging part here, and sometimes you're going to choose wrong. What are you looking for when you're choosing your w? Look at the ones we did right here. What do you notice about, what's the relationship between 3x squared and x cubed? What's the relationship? One is the derivative of the other. So what is the derivative of x cubed? 3x squared. That's what you're looking for. The w in this case would be x cubed. Exactly. So if we were to do this one with u-substitution, Connor, if we were to go back and do this one with u-substitution, let's say we just started with this, you would say w is equal to x cubed. So what does dw dx equal, Connor? Equals 3x squared. So that tells us dw is equal to 3x squared dx. So what does dx equal? dw over 3x squared. And now we substitute back in. We take this and we take this and we substitute both of these back in. And what do you end up with? The integral of 3x squared cosine of w. But instead of dx, what do you write? dw over 3x squared. What's the magical thing that cancels right here, Connor? What cancels now? Yeah, that's a really good thing to happen because it gets rid of the double variables. And now you just have this. What's the integral of cosine w? Negative what? Or sorry, no, it's just sine, sorry. Sine of w plus c, but what is w? Yeah, so you have sine of x cubed. That's how you would do this one with w substitution. Just as a side note, you might hear me say u substitution. That's the exact same thing. Some textbooks like to call it u substitution. Some textbooks like to call it w substitution. It's the exact same thing. Yes, Nick? Substitution, you're going to choose ones and get to a wall and be like, I can't do anything with this. Guess what? You probably chose the wrong w. And then what do we think this one is? I'm going to put a question mark and let you do that one in a second. So this is what I'd like you to do first. Find a piece of the board, everybody. Find a piece of the board. And I want you to try both of these right here. You guys did the new thing really, really cleanly. I like that you did the new thing really, really cleanly. So you knew that dw dx is going to be 4x cubed, right? That's what people got?
Yep.
Am I okay so far? So we knew that dw was equal to 4x squared dx. So we knew that dx was equal to dw over 4x cubed. Once you get this, you need to substitute both things. Those are the two things you need to substitute. So when you make the substitution on these, you're taking these things and throwing them up here. You end up with the integral of x cubed times the square root of w times dw over 4x cubed. What is the magical thing that cancels right now? What is the very magical thing that cancels right now? This is great. The x cubed. If that x cubed didn't cancel, you can't go anywhere. So the x cubes cancel, and that's awesome. And what can you factor out to the front? Oh, the 1/4. So many of you got to here, which is great. That right there is the majority of the problem. You are home free now. You're home free. You're home free. Best way to go about it is to convert it to the 1/2. And then that is the derivative of what? Well, it's 1/4 w. You increment the power by 1, and then you put it over like this. Because when you take the derivative, you want that 3/2 to cancel. So that's going to be 1/4 times 2/3 w to the 3/2 plus c. What's this? Oh, this cancels too, so it turns into what? 1/6 w to the 3/2 plus c. But you don't want w when you answer. What do you substitute? What is w equal to on this one? What is w equal to on this one? Oh, there it is. So what's the final answer of this one going to be? 1/6 times what? Times what? All raised to the what power? Plus, that would be the final answer right here. That's the final answer right there. Just any ideas? So we're stuck right here. This is where we're stuck, right here. I just wrote it a little differently. We're stuck because there's that w. Sorry.
Go back to dx and make dx or dw equal to
Something.
with an
Oh yeah. Well, actually, go back a little.
X cubes
Say it again.
Make dw go back up and use it as dw equals 4x cubed dx, because then we only have x as the value, and then you
Well,
use the value.
well, hold on. You're saying this right here?
Yeah, and then also use w with the x value in it.
You can't. So
W equals x to the 4 plus 5.
yeah.
You can do that, but you can all x it. Unless you want to keep it as w.
I'm sorry. The problem is, look. So you could substitute x, but the problem you could substitute x in, but then you're going to bring in a dx.
Yeah.
And then you still have the w. The thing, if you have w's, we only want dw's. If we have x's, we only want dx's. So you can go substitute. The question is, is there anything we can do? You're on the right track though, Lizzie. I like what you're thinking. Look at this. We chose this, right? We chose that as our u, correct? We chose that. We chose that as a w. This is a wall. We don't know how to get over it. So when you hit a wall and you're sure your algebra is correct, our algebra and our calculus is correct, our original assumption was that w should equal x to the 4th plus 5. Well, maybe it shouldn't. Maybe it should equal something else. Maybe it should equal something else. Maybe there is a different w to try. Maybe there's another w to try. Nick said we could just say, well, w is equal to this, right? And plug it in there. What do we end up with? 1/4 the integral of the square root. This is a great idea, but look at the problem, Nick. Is there any way to simplify that?
Oh, it's a square root.
Yeah, it's a square root w, right? So is there any way to simplify? If it was just x to the 4th plus 5, we'd be good. You're right, Nick, because it could simplify. But do we have any way to do that yet? We don't know how to undo the quotient rule. This is much harder. So we're stuck. The question is there anything? So when you went about doing this, let me unfreeze it here for you. When you went about doing this, the nice thing that happened immediately, you end up with sine theta, and then when you did the substitution, what was the awesome thing that happened immediately? What's the awesome thing that happened right now that makes you very happy? The signs cancel, and therefore you're down to how many variables now? Just one, just the w. So you end up with negative e to the w plus c, and w is cosine theta. And how would you check this? How do you check your answer? You take the derivative. Exciting. Okay, on your own, by yourself. Which one should we try? What should w be? Take a guess. Anything. What should w be? Come on. This is literally a guess. E to the t. If we did e to the t, if w is equal e to the t, we would say, not now, we would say dw dt is equal to what? What's the derivative of e to the t, kids? e to the t, yay! So dw is e to the t dt. So what does dt equal? What does dt equal?
dw over e to the t.
Perfect. So what's the integral become? What does the integral become? Do the substitution. W over what? 1 plus w times what? Over e to the t. What's the problem now? What's the problem? Well, we know w is equal to e to the t, right? There's two variables. So we could say e to the t over 1 plus w dw over e to the t. Hey, what cancels now? The e to the t cancels. Is that nice? Yeah, it is. Yay. So what are we left with? The integral of what? 1 over 1 plus w. How many variables are there? Is that a good thing that there's one variable?
Yeah.
It is a good thing that there's one variable. So if we want to integrate this, how could we rewrite that to make it nicer? Nope. Can't do that. Something to the what power? Oh, come on, kids. How can you rewrite that?
1 plus w to the negative.
Yeah, there you go. I would like you, it's going to be ln of what? ln of what? Plus w plus c. But what does w equal? E to the what? So it's going to be ln of 1 plus e to the t plus c. There it is, right there.